All right, so last problem here is 2002 question 3. An object moves along the x-axis in this position of 0, 2. So at time 0, it's at position 2. The velocity of the object at time t is given by the equation v of t equals sine pi over 3t. I have the answers minimized in black. We'll work through it in red and make sure they match. What is the acceleration of the object? Well, acceleration is the derivative of velocity. Now, this is a calculator section. I would just plug it in. Sine of pi over 3t, evaluated at 4 for the derivative. Let's just, for the sake of argument, I'm just going to take the derivative of sine, which is cosine, and it's a chain rule. So pi over 3t means there's a multiplier out there. And if I want to do this at 4, I can change the t here to 4. And now I would have to take my calculator, making sure that it's in radians. 4 pi over 3, all right? And actually, I could probably figure it out exactly, but when I do this in my calculator, what I had for an answer, and there it is, was negative 5.23, and the AP test gave credit for negative 5.242. So at time 4, the acceleration is negative. All right? The next one says, consider the following two statements. Statement 1, between 3 and 4.5, the velocity of the object is decreasing. Statement 2, for 3 and 4.5, the speed of the object is decreasing. All right, for both of these, I have to understand what's happening with the velocity and acceleration in that interval. And we get a little lucky here. For 3 to 4.5, problem A told us that the acceleration at 4, or acceleration in the middle of this interval, was less than 0. So I would take 4 again, and I would plug 4 into this equation and do sine of 4 pi over 3. 4 pi over 3 is in the third quadrant, so I know that's negative. All right? And again, you plug in your calculator radians, it'll tell you that. It'll give you some negative value. Let's be clear now. On the line, we think about this as a particle in between this interval. The velocity is this way, and the acceleration is this way. So they want to know, is the velocity decreasing? Well, it's negative, and it's getting more negative. So yes, the velocity is decreasing. Statement 1 is correct, because v of t is less than 0 and a of t is less than 0. Statement 2 is the speed of the object increasing. And again, this is going to be correct. All right? Because of the same 2. V of t is less than 0. A of t is less than 0. I think at this point, to explain it, you have to understand when it wouldn't be. All right? And I always use the example of thinking about driving a car in reverse. If I have forward being this way, and I have reverse being this way, if I am driving in reverse at 15 miles per hour and I start to accelerate the other way, my speed starts to go down. All right? My velocity is increasing because positive is to the right on the number line. Okay? If I'm driving in reverse and the acceleration is negative, it's getting more and more negative. You'll notice there the speed is increasing. So again, understanding the difference is important. In this case, really the rule is this: if velocity is greater than 0, acceleration is greater than 0, the velocity is increasing and the speed is decreasing. If the velocity is less than 0, the acceleration is less than 0, the speed is increasing, the velocity is decreasing, and everything in between, all right, is going to be a mixture. All right, you have to determine it out. I know that's right. All right, what is the total distance? Oh, is this one that missed a lot? Because a lot of people are going to do this. They're going to just put in v of t dt. And this does not give us distance. This gives us change in position. All right? It gives us change in position. It wants distance. So between 0 and 4, it probably does something like this. What the derivative, antiderivative here of this is going to do is it's going to tell us, maybe I get rid of this. The antiderivative here from 0 to 4 would tell us this. What we want is this, the longer So all we have to do in the calculator section is know that we have to tell it we want distance. And now it's not distance, now it is, now it's not position, I should say, now it's distance. So I put D equals. And I would just type that in my calculator, all right, because this is a calculator section. And again, I assume up here I got this. Oh, and there's the note. Yep, and it comes, you'll see it right there, 2.378 is the answer. Last one. What is the position? Okay, now, again, this gets missed a lot because what students, again, do is they don't do the whole problem. They see position and they just go 0 to 4, d of t dt. That's the change in position. We have to use the fundamental theorem of calculus and know that we have to give it an initial condition. All right, and again, I can just type this in my calculator, and there it is. Oh, look at that. I have the equation right there in black. And this condition was 2, so the answer is 3.432. Pretty easy problem, moving a particle along the line. Again, it's critically important to realize that derivative of position is velocity, and the double derivative of position is the single derivative of velocity is the acceleration. Keep practicing. AP's a coming.